All right, guys. Let's get back to it. I want to do two quick little problems, considering that I've got this already set up, to show you there's two main pieces of terminology we use in this chapter. One is called mutually exclusive, which we'll talk about in a minute, and the other one's called independent events. If two things are independent, what would you say about them? Two things are independent. They don't have to be different, right? They don't depend on each other.
The probability of one happening doesn't affect the...
All right, that's a very technical, yes. So, yeah, in general, if two things are independent, this thing doesn't give a shit what this thing does. It's not affected by anything this guy does. So in terms of probability, it would be, if I knew one thing happened, does it change the probability of the other? So for example, what's the probability you show up late to a class? Okay, that's something. What's the probability you show up late to a class, given that you were out till 2 in the morning last night drinking 7 drinks? That kind of goes up, don't it? So would you say those are, well, depending on who you are, but in general, the probability of anybody? You can say, nah, man, 7. That'll just start. They are dependent because if one of the events happens, the other event's probability changes. All right. I don't know why I keep doing the same thing, because I got in trouble one semester for this and I don't apparently give a shit. All right, let's see if you guys can handle this. Let's say off in the distance, I see somebody walking towards me, and they're so far away, they got a long ass hair. I don't know if they're a man or woman, right? It could be either one. So what's the probability they're a man? 50% roughly. It's a little bit higher than 50, but we'll say 50% for a man. Let's say that I saw them get off of a Harley Davidson motorcycle. Is the probability they're a man still 50%?
Yeah.
It's gone up. And the reason I got in trouble is I love it. This one semester, this girl just let me say, "Are you saying that women don't have?" No, I never said that. We're talking about probability. Somebody's riding a Harley Davidson motorcycle. You got to put money on it them being a man, or you got to put money on them being a woman. And I love some of you guys are looking at me like, "What are you all about?" I am talking about probabilities. I am not talking about, right? And I don't know why I keep doing this to myself, but it's probabilities. I am not saying that there are no women that ride Harley Davidsons. The more you can understand this, the more you see what probabilities are. Somebody gets off of a Harley Davidson, I'm putting money on them being a man. Does that mean that I know they're a dude? No, it means the probability that they're a dude is higher. So if something happens and it changes the probability of something else, they're dependent. Does that make sense? If something happens and the other guy's probability stays the same, this guy didn't give a shit about him. That would be independent. They wouldn't care about each other then, right? Okay, I like it. So you cannot answer a question about independence without looking at a probability of how they interact with each other. I'll say that again in a bit. You'll see. So, what's the probability I pick a woman out of this set of data? 34 out of 64, and that was, what was that, 0.53, what was it? 5313. All right, now watch. What's the probability I pick a woman given that they said no? So how do I do that? What goes on the bottom of this one? So it's its own question. It almost has nothing to do with what I just talked about yet. Just how do I calculate the probability of woman given they said no? So how many people am I talking about? 25 people said no. And out of those, how many are women? 5. 5 out of 25 is 1/5. It's 20%. Now watch this. This is the thing. This is one of the things that really drives me a little insane, because it really isn't more than this. What was the probability that somebody is a woman? 53%. Does the probability somebody is a woman change if I know that the person said no?
Yeah.
So they are dependent. The probability it's a woman depends on if they said no or not. Well, how can I tell? What did I have to calculate to check that? How they interact with each other. That's a given. The given is the only one that tells me how they interact with each other. So since the probability of woman given no does not equal the probability of woman, they are dependent. Does the probability they're a woman stay the same if I find out later that they said no? Does the probability they're a woman stay the same if I found out later that they said no? No, it doesn't, right? It changes. Therefore, it depends on if they said no or not. You guys love that shit. But I really hope this. So the probability of one event. See how they're both questions about probability as a woman? This one is if I happen to know that they said no. Since the probability changes, it's dependent. The probability they're a woman is dependent on if I know their answer or not. Maybe. So the general test for independence, if I ever say, are these two things independent, you must check. Check what, Jeff? I don't know. Test for independence. If the probability of A given B equals the probability of A, then they are independent. And vice versa. Independent, see, I love the word independent. Independent, there it is. It's really like banana. So when the hell is this stuff? So you can't tell me, if I said it's the probability of, I don't know, a man, and probably they said no. Well, the probability they're a man does not equal the probability they said no. That doesn't mean it. The probability that I flip a head is not equal to the probability I get a 1 on a die. That has nothing to do with how they interact. One of the things you check has to be the given to see if they actually affect each other. Maybe. All right, so what I want to do is, I think I've just decided this as I was standing there. I've been talking so damn much today. Here's a little handout. You can really only technically do the first problem, so that's what I want you guys to focus on. If you want to look at the rest of it, great, but I haven't really talked about the rest of it yet. But I want to shut up for a while. I'm getting on my own nerves. There's a side that says this side in class. That's the side you want. You would do the first problem.
What other methods?